The headlines, they promise Hollywood-level AI movies. Just from a few words, you see these incredible clips online and you think, wow, the era of limitless creation is here. But the reality is, making a full story, where the main character doesn't change their face or their voice every 8 seconds, that's actually the #1 technical challenge right now.
Yeah, it really is.
So today, we're diving into the systematic process that actually, well, solve that consistency problem.
Welcome to the deep dive. We've got a, I think, really necessary, repeatable 4-step method. It basically turns those chaotic, one-off AI video clips into something continuous, a coherent story.
Right.
And this is pretty critical for anyone hoping to graduate from just generating cool, isolated shots to actually crafting a real narrative.
That's the mission for today. We'll show you exactly how to set up your characters, let's call it DNA, using just a single static image. Then how to lock that visual identity into every scene afterwards.
And crucially, that final step, fixing the audio inconsistencies, because those just instantly ruin the immersion, don't they?
They absolutely do.
So this is your operational blueprint, really, your shortcut to getting reliable AI storytelling. We're going to cut through the hype and give you the actual workflow reality.
Okay, let's unpack this core issue then.
Yeah.
We kind of assume AI remembers things, right? If you use an LLM for a story, maybe a specialized ChatGPT, the characters stick. The model holds onto that context. But why is it that when we shift to AI video, that memory just seems to vanish completely?
Yeah, that's the blank slate problem. And it's fascinating, really, because the underlying tech is just fundamentally different. LLMs, they work with tokens, text, they have a context window, a kind of working memory.
Okay.
But when you generate video, usually with a diffusion model, you're often starting from pure noise. You're generating pixels, not words.
Starting from noise.
Right, exactly. So every single time you ask the tool, make me a clip, it genuinely starts fresh. Even if you feed it the exact same words, the random noise seed is different, the output's slightly different.
And poof, continuity is gone.
Gone immediately. The model just doesn't have that built-in persistent memory for a character's visual look across generations.
So it's not that the system is actively trying to forget our character. It just, well, it lacks the architecture to persistently remember visual details when starting a new task.
Precisely. You'll get that perfect 8-second clip. Your brave knight, shining armor, looks great.
Yeah.
Then you generate the next scene, maybe the knight walking into a castle, and suddenly the armor shifts from silver to, I don't know, bronze. His face looks 5 years older, maybe. And the voice, totally different.
It completely breaks the suspension of disbelief. As a viewer, you immediately feel like, okay, this is kind of amateur.
It does. And, I still wrestle with prompt drift myself sometimes if I don't use a really strict external reference. It's a very, very common frustration, even for people doing this a lot.
So if the tools themselves lack that core internal memory, what's the fundamental idea we need to use instead? How do we externalize that character identity?
Well, we have to externalize the memory. And we do that using a single, consistent visual reference image.
Okay, step 1. It sounds a bit counterintuitive for making video, doesn't it? We start by creating a single, still picture. Why is this character image the DNA for the whole project?
That picture becomes the immutable reference point. It's what you feed back to the AI again and again to basically force consistency.
Okay.
The key here is extreme, almost surgical detail in that first prompt. You need to define every little pixel of that character you want.
So you can't just say a robot. You've got to blueprint the character meticulously.
Absolutely. Think like an engineer designing it.
Like the example prompt. A friendly, futuristic robot librarian. Smooth, white metallic body, glowing blue lines. Simple dome head, large digital visor showing friendly animated eyes, wearing a smart gray vest. That level of detail.
That's the specificity you need. And here's an important little technique at the start. Turn off any style consistency settings when you're creating this very first image.
Ah, okay. Why is that?
You want the AI to give you maximum creativity initially. Let it explore a bit. Then you review the options and pick the single best, usually of a full frontal view image, that nails your vision.
Okay, that makes sense. But let's say I love the white robot librarian I got, but maybe halfway through making my video, I think, those blue lines, maybe they should be a warm orange instead. If I just change the prompt text, won't the whole robot image drift?
Well, that depends on the settings you use next. If you just edit the text prompt alone, Yes, you absolutely risk drift. Things will change subtly all over.
Right.
This is where the tools offer features usually called something like precise reference or maybe structure reference. You have to use one of those.
Okay, walk us through the difference there. Precise versus structure reference.
Sure. So if you choose precise reference, you're telling the AI to lock pretty much everything.
Mm,
The texture, the color, the fine details. Then, if you prompt for orange lines, the AI really tries hard to change only the lines while keeping everything else identical. Now, if you choose structure reference, you're locking more the skeleton or the pose, the overall shape. So with structure lock, you could maybe change the material from metal to wood, but the robot would keep its exact shape and stance.
I see.
For character consistency, like keeping the robot looking like the same robot, we generally stick with the precise option.
So that precise lock lets you make small, controlled changes like the line color without the whole character morphing into something else.
That's the nuance, exactly. And that brings us neatly to step 2, the starting frames. We take that perfect reference image we made,
The DNA
the
image.
DNA image, right. We upload it, and critically, we make sure that precise reference feature stays on. Now we're setting the stage for each scene.
So we're creating the static starting point for each video clip. We place our locked character into a new background and new environment. Let's use the contrast examples. Scene 1. The
Yeah.
robot is pointing to a book for a young student.
And then scene 2. Same robot, but now it's leaning forward, maybe listening carefully to an elderly man sitting in a comfy armchair.
Right.
And the key is the robot's face, its body, those color lines, they look visually identical across both of those static frames. It's only the background and the other people that change.
The reference image is really doing all the heavy lifting for consistency there. So when moving from step 1, creating that reference, to step 2, making these starting frames, what's the immediate problem if someone forgets to turn that precise reference or locking feature on?
Well, the character will immediately start to drift in the new scene. It might pick up lighting cues or color tones from the new background, and bam, you're right back to square one with inconsistency.
Okay. Step 3 is where things actually start moving. We take that static frame from step 2, the one with the locked character in the scene, and we use an image-to-video tool to bring it to life.
Yeah, this is where the magic happens. But it's fragile magic, you know? We're telling the AI what should move and, just as importantly, how it should move.
Right.
This requires really precise instructions about the motion, the choreography. It's not just describing the background anymore.
So we need another super detailed prompt, but this time focusing on the action. Just saying, the robot points its finger up at the book.
Yeah.
That's not going to cut it anymore, is it?
Absolutely not. We have to be directive, tell it the pace, the scope of the movement. So for that first clip, the robot and the student, the full prompt needs to be something like that.
Okay.
The robot librarian points its finger up at the book. Its blue visor blinks slowly. The young girl looks up. Then maybe add camera direction. The camera slowly pushes in towards the girl's face. Both characters are relatively still. The movement is very gentle. Make the scene 8 seconds long.
Whoa. Okay, imagine having a system that can reliably take those super precise, gentle motion instructions, turn them into a cohesive 8-second clip, and then do that consistently across, say, 100 scenes. That's the real power we're trying to unlock here.
It really is. It's all about control. And an advanced tip here, technically, sometimes you need to use what's called prompt weighting syntax, things like using parentheses or special keywords.
To tell the model what's most important.
Exactly, to tell it, okay, focus maybe 90% of your effort on this slow camera push and only 10% on the robot's little secondary action, like the blinking.
That helps systematize the prompt engineering, doesn't it?
Yeah.
Makes scaling it up feel more achievable. Which leads to the idea of maybe using a prompt helper,
Yeah.
like creating a custom AI assistant, maybe a specialized Gemini or something, whose only job is to translate a simple idea like robot shows the girl a book into that really technical, weighted, super detailed video prompt.
That's absolutely the way forward for efficiency. You systematize the inputs to try and stabilize the outputs.
So if the goal here is both consistency and quality in these video clips,
Yeah.
what's the one cardinal rule a creator should never break when actually generating the video in step 3?
Oh, simple. Never generate only one video output. You absolutely must create multiples, I'd say at least 3 to 5 versions of each clip so you can pick the best one. You need quality control, looking for glitches, weird flickers, distortions.
Right. Always generate options. Okay, so we've worked through visual consistency with the first 3 steps: reference image, starting frame, motion generation. But the second huge technical trap is audio.
Big one.
Our robot now looks identical in every scene, which is great. But when it speaks, it might sound like a completely different actor in every single clip. How do we fix this immersion-breaking problem?
Right. We have to isolate the audio and treat it completely separately. That's step 4. You pretty much have to use an external voice cloning or a text-to-speech service, something like 11 Labs, for example.
Okay.
The goal is to create a single consistent voice for your character.
So we pick one definitive voice, let's call her Rachel, for our robot, and that specific voice profile will be used for our robot across every single scene it speaks in. Doesn't matter what prompt we use for the video itself.
Correct. So the workflow usually starts with scripting the dialogue first. Then you take your final video clip, upload it to the voice tool, choose your specific voice profile, Rachel, and generate that new, clean, consistent audio track just for the dialogue.
And this process, it has to be repeated meticulously for every single scene where the robot speaks, right? Using the exact same voice model, the same settings, every time.
Exactly. It's repetitive, yeah, but that's the only way to guarantee audio consistency for that character.
Now, you mentioned this is the difficult part,
Yeah.
the final edit. So we have our video clips with consistent visuals, and we have our new consistent Rachel audio tracks for the robot's lines. But the original video clips, they have audio too, right?
Well, they do, and it's usually unusable because it's inconsistent or just noise. So in your video editor, the first thing you do is mute the original audio track from the video clip completely. Just silence it.
Okay, easy enough. But wait, if our voice tool, like 11 Labs, processes the dialogue, doesn't it usually process all the dialogue in the clip?
Yeah.
What about the voice of the young girl or the elderly man? Wouldn't they also sound like Rachel?
Yes. That's the flaw you typically have to fix manually. Often, the voice tool will change all the voices in the segment to your chosen one, the robot voice in this case.
So everything sounds like the robot.
Potentially, yes. So you have to do some careful audio surgery in your editor. You need to identify precisely where the robot stops speaking and say, the girl starts.
Right.
You keep the robot's original track muted. You place the new, clean Rachel audio track for the robot's lines. But then you have to painstakingly cut out the parts of that new Rachel track where the girl was supposed to be speaking.
And let her original audio come through.
Or replace it, too.
Exactly. You either let her original generated voice come through from the muted track by unmuting just those sections, or ideally, you generate another consistent voice for the girl using the same process and layer that in.
Wow, okay. That is intricate. That's like frame-accurate audio editing. Step 4 isn't just clicking Generate Audio. It's manually solving a multi-voice synchronization and replacement puzzle in a final video editor.
It really is. It's the necessary final polish. And then adding some subtle background sound, like a constant library hum or room tone throughout the entire scene that helps mask any tiny imperfections from the cuts and really completes the illusion of quality. So if a creator just skips this whole audio workflow, ignores step 4, what's the immediate flaw that every single viewer is going to notice, even if the visuals are absolutely perfect?
Oh, it's instant. Inconsistent character voices just make the whole thing feel amateurish or kind of cheap, cobbled together. It completely shatters the believability.
Okay, let's think about scaling this up. What if we have multiple recurring characters, like our robot librarian and, say, a little floating drone sidekick that follows it around? How does this 4-step method handle that added complexity?
Well, the process is fundamentally the same, but you basically duplicate the complexity and maybe even square it.
Okay.
You generate a separate reference image for each character. Robot A gets an image, drone B gets its own image. Then in step 2, setting up the scene frames, you'd ideally upload both reference images. But now you run into the challenge of regional prompting.
Regional prompting. You mean telling the AI which reference image applies to which part of the scene? Like this blob is the robot, that blob is the drone?
Exactly that. Because without more advanced tools, maybe like masking, if you just upload 2 reference images in a scene prompt, they often conflict or kind of blend together into mush.
Right.
You need to use advanced prompt syntax or specific features, if the tool supports it, to say, okay, apply robot A's reference to the character in the center. Apply drone B's reference only to the object in the top right of the frame.
That sounds like a significant technical hurdle that wasn't obvious in the simple one-character workflow.
It definitely is. It adds a layer of complexity. And then, of course, in step 4, the audio, you need to select 2 distinct, consistent voices, maybe Nova for the robot and a higher-pitched, whirring Sparky for the drone. And then in your final edit, you're managing potentially 3 separate audio tracks that need careful cutting and syncing: the robot track, the drone track, and any human character tracks.
Okay, that paints a clearer picture of the real work involved. Now, we hear constant news about next-generation tools. Models like Sora, they talk about built-in features like Cameo or continuity. Does this whole four-step multi-tool method we've outlined, does it become obsolete once those tools launch widely?
I really don't think so. Not completely, anyway. That Cameo feature, from what we understand, seems focused on tracking real people across clips to keep them visually consistent. That doesn't directly help you create and maintain a fictional character, like our specific robot librarian design.
Okay, that makes sense. And what about the promised recut or continuity features?
Those sound like they'll help smooth out transitions between generated scenes, maybe ensure physics remain stable, things like that. It's more about the quality control of the video generation itself. It still doesn't seem to solve the fundamental problem of creating the consistent character look in the first place, nor does it solve the absolutely critical issue of multi-character audio consistency. So I think this four-step method, or something very like it, remains the essential backbone of the production strategy for the foreseeable future.
So the realistic toolkit picture emerges. To make even that short, consistent video of the robot librarian, we potentially ended up using, what, up to 6 different specialized tools?
Yeah, let's count them. You've got your image creation tool for step 1, your scene framing tool or feature for step 2 using the reference, maybe an optional AI prompt helper, then the core image to video tool for step 3, the external voice tool for step 4's audio generation, and finally, a complex video editor for step 4's audio fixing and final assembly.
It's really a pipeline, isn't it? Not a single magic app.
It's absolutely a workflow, a pipeline. So looking at this complex multi-tool approach, what do you think is the biggest trap related to just strategic planning that creators need to consciously avoid?
I'd say rushing those crucial early steps. If you rush the character design in step 1, if you settle for a mediocre reference image, all the complexity and effort you put into the next 5 tools, it just ends up amplifying that initial flaw. Bad character design inevitably leads to a bad final video, no matter how fancy the tools are later.
That's spot on. So the core takeaway for you listening is pretty clear. Consistent AI video isn't achieved by some single magic button right now. It's about intelligently combining several specialized tools into this reliable 4-step process.
Right.
You start with that solid reference image. You move to careful starting frames for each scene. You ensure quality movement generation with detailed prompts. And then critically, you tackle the audio correction manually and meticulously.
The consistency of your characters visually and audibly. It's now entirely in your hands, really, through disciplined execution of this kind of process. And this applies everywhere, doesn't it? Consistent marketing mascots, characters in explainer videos, virtual presenters for education.
Any project needing consistency. Planning that reference image properly up front, that's the key to unlocking success for all those projects.
So what's the best way to actually learn this?
Honestly, just start small. Grab the tools you have access to, pick a really simple character idea, and just dedicate some time to practicing each of these 4 steps. Get a feel for it today.
Okay, so we've kind of solved the technical challenge of consistency, which turns out to require combining maybe half a dozen different tools intelligently.
Yeah.
But if AI creativity right now means we have to constantly patchwork these specialized services together, will this fractured workflow ever really converge into a single cohesive interface? Or is managing this complex multi-tool pipeline actually the future of deep AI creativity? That's something for you to mull over.
Thanks for diving deep with us today.
We'll catch you next time.